Green chemistry, a sustainable approach to tackle emerging contaminants. Green chemistry, a sustainable approach to tackle emerging contaminants. Emerging contaminants represent a major challenge for the environment and human health. These are chemicals that were not known or regulated previously, but have now been found to have harmful effect. On the ecosystem and public health. Some examples of emerging contaminants include pharmaceuticals, personal care products, pesticides, flame retardants, and industrial chemicals. These pollutants are often detected in water bodies, soil, and air, and pose a threat to biodiversity, food chains, and human health. Traditional methods of treating contaminants, such as physical or chemical techniques, have limitations as they may not be effective enough to remove emerging contaminants. Furthermore, they can generate waste and promote the production of toxic byproducts. This is where green chemistry comes in. It provides an alternative approach to conventional chemical processes that limit waste, use renewable resources, and minimize toxicity and hazards. Green chemistry offers a set of principles that can be implemented to prevent the formation of unwanted chemicals or promote the use of safer alternatives. One of the key principles of green chemistry is to design chemical processes to minimize the use and production of hazardous substances. This means that the starting materials, reaction conditions, and end products should be selected based on their environmental impact. For example, pharmaceutical manufacturers can minimize the use of solvents and reagents that are toxic or non-biodegradable during the production of drugs. In addition, the development of new drugs can take into account the environmental fate and toxicity of the byproducts that are generated during their metabolism. Another important principle of green chemistry is to use safer and renewable resources whenever possible. This includes the use of renewable feedstocks such as biomass, instead of fossil fuels, to produce chemicals. Furthermore, the use of biocatalysts such as enzymes can provide an environmentally friendly approach to perform chemical transformations in a selective and efficient manner. Green chemistry can also promote the use of benign solvents and technologies that reduce waste and energy consumption. This can be achieved by replacing hazardous solvents or reducing the amount used. By using water or supercritical fluids. Supercritical fluids have properties of both liquids and gases and are useful for extracting or purifying substances. Additionally, emerging technologies such as microfluidics and nanotechnology can enhance chemical reactions and reduce the amount of waste generated. For example, microreactors can provide a high surface area to volume ratio, enabling tear reactions with lower volumes of chemicals. Green chemistry provides many opportunities for the treatment of emerging contaminants, including the development of safer and more effective methods for their removal. One such method is photocatalysis, which uses light to activate a catalyst that can break down pollutants into harmless byproducts. In photocatalysis, nanomaterials such as titanium dioxide can be used as the catalyst to convert contaminants into carbon dioxide and water. This process can be applied to the treatment of water, air, or soil, as well as for the removal of odors. Another green chemistry approach to tackle emerging contaminants is bioremediation, which uses microorganisms to break down pollutants into less harmful compounds. Bioremediation can be used to treat soil, water, or air, and can be applied to a range of contaminants such as pesticides, petroleum products, or heavy metals. Microorganisms such as bacteria and fungi can be used to degrade the contaminants, and this process can be enhanced by adjusting environmental conditions such as temperature, pH, and nutrients. Bioremediation can be a cost-effective and environmentally friendly way to REMO. Evade contaminants and restore ecosystems. Green chemistry can also promote the development of innovative materials that have improved properties for environmental applications. Materials such as zeolites, activated carbon, and biochar can be used to remove contaminants from water or air. Zeolites are porous minerals that can selectively adsorb pollutants, while activated carbon and biochar have high surface areas and can adsorb a range of organic and inorganic contaminants. These materials can be modified to enhance their properties, such as by the addition of functional groups that can target specific contaminants. One of the challenges facing the adoption of green chemistry is the lack of awareness and education among chemists, policymakers, and the general public. Many chemical processes and products are STI LL designed without considering their impact on the environment and public health. There is a need for education and training programs that promote the principles of green chemistry and encourage the adoption in industry, academia, and government. For instance, the Environmental Protection Agency, EPA, has established a program called the Green Chemistry Challenge Awards to recognize and promote innovations in green chemistry. Moreover, academic institutions have a crucial role to play in promoting green chemistry by incorporating it into their curricula and research projects. In summary, the adoption of green chemistry principles offers a promising approach to tackle emerging contaminants and promote sustainability in the chemical industry. By designing chemical processes and products that are environmentally friendly, we can prevent and reduce the impact of pollutants on the ecosystem and public health. To achieve this, however, we need to raise awareness, provide education and training, and encourage the implementation of green chemistry principles in industry, academia, and government. By working together, we can create a more sustainable future for ourselves and future generations. Another challenge in the adoption of green chemistry is the issue of cost. While green chemistry principles can lead to cost savings in the long run, the initial investment required to switch to a green approach can be a barrier. This is particularly true for small and medium-sized enterprises that may not have the resources or expertise to develop and implement green chemistry practices. 2a. Address this, incentives such as tax credits, grants, and loans can be provided to encourage the adoption of green chemistry. Governments can also provide support for research and development of green chemistry technologies and processes. Another important consideration is the need for international collaboration and cooperation to address the global challenge of emerging contaminants. Many emerging contaminants are not regulated or monitored globally, which can lead to disparities in exposure and risk across different regions. In addition, the sharing of knowledge, best practices, and resources can help accelerate the development and adoption of green chemistry practices worldwide. While the implementation of green chemistry principles is an important step towards addressing the challenge of emerging contaminants, it is not a panacea. For example, the use of pharmaceuticals and personal care products can also contribute to the emergence of contaminants in the environment. Addressing these issues requires a combination of consumer education, policy interventions, and technological solutions. Moreover, the distribution and exposure to contaminants are not evenly distributed, with marginalized communities often experiencing greater exposure and health risks. This highlights the need for an equity-focused approach to addressing emerging contaminants, which addresses issues of social justice alongside environmental and health concerns. In summary, the challenge of emerging contaminants requires a multifaceted and collaborative approach that considers scientific, social, economic, and political factors. The adoption of green chemist right principles is an important step towards promoting sustainability in the chemical industry, but it alone is not sufficient. By working together towards a more comprehensive and equitable approach to addressing emerging contaminants, we can protect the environment and public health for present and future generations. Thanks for watching.